Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105.
This video is all about my second summary of the chapter 5 and the chapter 5 entitled Ethernet. So the Ethernet protocol, Ethernet frame, Ethernet encapsulation. So Ethernet operates in the data link layer and the physical layer. So we can see or the Ethernet operates in the data link layer and the physical layer. So Ethernet supports data bandwidth from 10 Mbps through 100 Gbps. Then the bandwidth of the Ethernet is from the 10 Mbps up to 100 Gbps. Then Ethernet standards define both the layer 2 protocols and the layer 1 technologies. MAC sublayer. MAC constitutes the lower sublayer of the data link layer. So it says here that the MAC sublayer it constitutes the lower sublayer of the data link layer, then responsible for data encapsulation and media access control. So it says here that the MAC sublayer is the responsible for the data encapsulation and the media access net control. Then Ethernet evolution. Ethernet has been evolving since its creation in 1973. So, the Ethernet invented or created in 1973, the Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. Ethernet frame fields. The minimum Ethernet frame size is 64 bytes and the maximum is the 1518 bytes. So, uh, the minimum of the Ethernet frame size is 64 bytes and the maximum is 1518 bytes. Then, frame smaller than the minimum or greater than the maximum are dropped. So, it is if the frame is smaller than the minimum, so it will be dropped. And if it is also greater in the maximum, it also drop also. Then drop frames are likely to be the result of collisions. So the drop will be the result of the collisions or other unwanted signals and are therefore considered invalid. So the drop frames will consider the invalid. Then Ethernet MAC addresses. An Ethernet MAC address is a 48-bit binary value expressed as 12 hexadecimal digits per bit per hexadecimal digit. So it says here that the Ethernet MAC address is a 48-bit binary, so expressed as 12 hexadecimal. Then 12 hexadecimal and 4 bits per hexadecimal digit. Just as decimal is a base 10 number system, hexadecimal is a base 16. So, it says here that the decimal has a base of 10 and the hexadecimal has a base of 16. The base 16 number system uses the numbers 0 to 9 and the letters A to F. So, the base 16 is for the hexadecimal. So, the hexadecimal uses the 0 to 9 numbers and A to F letters. Then MAC address representations. MAC addresses can be represented with colons, dashes, or dots and are case insensitive. 00-60-2F-3A-07-B6, comma 00 colon 60 or 60 colon 2F colon 3A colon 07 BC, comma 0060 or 60 dot 2F 3A dot 07 BC and 00-60-2F-3A-07-BC are all valid representation of the same MAC addresses. So it says here that it is all accepted or it's also the same MAC address. Then Unicast MAC address. Unique address used when a frame is sent from a single transmitting device to a single destination device. The source MAC address must always be unicast. So it says here that the source uh, always be unicast. Then the broadcast MAC address used to address all nodes in the segment. Then the destination MAC address is the address of FF-FF-FF-FF-FF-FF in the hexadecimal, 48 ones in binary. Multicast MAC address used to address a group of nodes in the segment. The multicast MAC address is a specific value that begins with 01-00-5E in hexadecimal. So, this is the multicast MAC address in specific value. So, they are it begins with 01-00-5E. The remaining portion of the multicast MAC address is created by converting the lower 23 bits of the IP multicast group address into 6 hexadecimal characters. Then the LAN switches. The MAC address table. Switch fundamentals. An Ethernet switch is a layer 2 device. So the Ethernet switch is the layer 2 device. Then it uses MAC addresses to make forwarding decisions. The MAC address table is sometimes referred to as a content addressable memory or the CAM or the COM table learning MAC addresses. Switches dynamically build the COM by monitoring source MAC. So it uses for the monitoring the MAC. Every frame that enters a switch is checked for a new addresses. The frame is forwarded based on the COM. So it always be based on the COM. Then filtering frames. Since the switch knows where to find the specific MAC address, it can filter the frames to that port only. Filtering is not done in the destination MAC is not present in the COM. So switch forwarding methods. Frame forwarding methods on Cisco switches store and forward. So it means that after it's stored, it will be forward. Then the cut through switching. Fast forward switching. Lowest level of latency immediately forwards a packet after reading the destination address. Then in the cut through, it will not store. Uh, uh, While the store and forward, so it will store first, then it will forward. Then typically cut through method of switching, fragment-free switching. Switch stores the first 64 bytes of the frame before forwarding. Most network errors and collision occur during the first 64 bytes. Then memory buffering on switches, port-based memory and the shared memory. Switch port setting. Duplex and speed setting. Full duplex, both ends of the connection can send and receive simultaneously. So in the full duplex, so uh, uh, the two PC can send and receive the data at the same time, simultaneously, while the half duplex is only one end of connection can send at a time. So in the half duplex, so one PC will send at a time, and if the one PC will send, the another PC will receive. Then uh, In the short term, so it is one at a time. Then common cause of performance issues on Ethernet links is when one port on the link operates and at half duplex and the other on full duplex. So that is the common performance issue on Ethernet. Then the address resolution protocol, MAC and IP. The combination of MAC and IP facilitates the end-to-end communication. Layer 2 Layer 2 addresses are used to move the frame within the local network. Layer 3 addresses are used to move the packets through the remote network. So Layer 2 for local network and the Layer 3 is for the remote networks. Then the destination on same network, the physical address or the MAC address is used for Ethernet NIC to Ethernet NIC communications on the same network. Destination on remote network. Logical address is used to send the packet from the original source to the final destination. The ARP. Introduction to ARP. ARP allows the source to request the MAC address of the destination. The request is based upon the layer 3 address of the destination. The ARP function. Resolving IPv4 addresses to MAC addresses, maintaining a table of mappings. ARP uses ARP request and ARP required to perform its function. So, um, the ARP uses the ARP request and ARP reply. Then, removing entries from a ARP table. Entries are removed from the device ARP table when its cache timer expires. So, the timer expires, so it will remove the entries from the device of the ARP. Then, cache timers are OS dependent. ARP entries can be manually removed via commands. ARP tables on iOS show IP ARP. On Windows PC, so ARP space dash A. So the ARP issues. ARP broadcast. ARP request can flood the local segment. So the flood is the issue of the ARP. So if it is flood with the local segment, so it will become an issue. ARP spoofing. Attackers can respond to requests and pretend to be providers of services. So the example of this one is the default gateway. So thank you. So that's all for this video. Thank you for watching.